Right, so we are going to start with the first question. It reads, simplify 2a minus 7b minus 2 open bracket a minus 3b. Right, so to simplify is to shorten. We want to remove the brackets and then collect like terms. So we are going to say 2a minus 7b. Then when expanding this bracket, you need to be very careful of signs. So when I talk of signs, I mean negative times negative, it gives you a positive result. Negative times positive, it gives you a negative result. Minus 2 times a, you get minus 2a, right? Right. So before you multiply 2 and 3b, you need to multiply the signs first. The negative sign on 2 is going to multiply the negative sign on 3b before you multiply 2 and 3b. So according to multiplication, negative sign times negative sign, it gives you a positive sign. So negative times negative, you get a plus. Then 2 times 3b, it gives you 6b. We now want to collect like terms. Remember, the question is requiring you to simplify. So 2a is a term in a, which is a like term with minus 2a, right? Then minus 7b is a like term with plus 6b. So what is 2a minus 2a? 2a minus 2a, you get a 0, and there's no need for you to write down the 0. Then minus 7b plus 6b, you get minus 1b. So minus 1b can be written as minus b, and this is your final answer. Question number 2 is requiring you to factorize. So if you look at the fraction x squared and 4y squared, you can notice that x squared and 4y squared is a perfect square. Remember, a perfect square is a number with non-root. You know that square root of x squared, it gives you x. Square root of 4, you get plus or minus 2. Square root of y squared, plus or minus y. Square root of x squared is plus or minus x. So you can notice that if you put a square root on x squared, you get plus or minus x. If you put a square root on 4, you get plus or minus 2. A square root on y squared, plus or minus y. It simply means that the entire fraction x squared over 4y squared is a perfect square. Same applies on the right side. 1 square root of 1 is 1, square root of 9 is plus or minus 3. So 1 over 9 is also a perfect square. So we want to apply the difference of two squares. So I'm going to put 2 brackets. Then square root of x squared, you get x, over square root of 4, it gives you 2. Square root of y squared, it gives you y, right? Then you put this negative sign here. Square root of 1, you get 1. Then square root of 9, it gives you 3. So for difference of two squares, you must have 2 brackets, right? But one of the brackets must contain a negative sign, and the other one must contain a positive sign. So since this first bracket is used the negative sign, it means the second bracket is now using a positive sign. Using the same terms, we are saying x over 2y plus 1 over 3. And this is your final answer. Let us move on to question number 3. Given that matrix 3x minus 5, 1, 4, 3 is equals to 14 minus 17, find x. So what you need to do here is you multiply the matrices on the left side first. You combine the two. So when multiplying matrices, you make use of row by column. Rows are found in the first bracket and columns are found in the second bracket. I hope you are listening, guys. So if you look at the first matrix, it is a 2 by 2. Then the second matrix is a 2 by 1 matrix. So it means it is possible for you to multiply if these two numbers are similar. It means bracket, the first matrix and second matrix can multiply each other. But the first number here and the last number here, they denote the outcome or the order of the answer that you get when you multiply the two matrices. So the outcome is going to be a 2 by 1 matrix. So a 2 by 1 has got one number above and one number below. So I'm going to put a bracket to calculate the number above, another bracket to calculate the number below. So to calculate the bracket above, you make use of the top row, which is 2x. Then you multiply this top row with this column, 4, 3. The first number in the row multiplies the first number in the column. So you are saying 2 times 4, you get 8, then you put plus. Then you say the last number in the row multiplies the last number in the column. So x times 3, it gives you 3x. So this is how you obtain the top number of the 2 by 1. Then to find the bottom number, you make use of the bottom row, which is minus 5, 1, to multiply the column 4, 3. So minus 5, which is the first number in the row, multiplies the 4, which is the first number in the column, you get minus 20. Then 1 times 3, it gives you 3. Then you equate to 14 and minus 17. I hope you are listening. So what is 8 plus 3x? It remains 8 plus 3x, since 8 and 3x are not like terms. Then minus the 20 plus 3, you get minus 17. Is equals to 14 minus 17. So you can clearly notice that since minus 17 on the left is equal to minus 17 on the right, it simply means 8 plus 3x is also equal to 14. So this equation, 8 plus 3x is equals to 14. It will then help you to find the required value of x. So you collect like terms by moving 8 to the right side, and 8 become negative 8, since if a term crosses over equal sign, it mutates its original sign. You get 3x is equals to 6, 14 minus 8 is 6. Then divide both sides by 3, x is equals to 2, and this is your final result. Stay tuned as we move on to question number 4. Two things are geometrically similar. If the ratio of their volumes is 27 as to 64, find the ratio of their curved surface area. So in simple terms, they want you to find the area factor. So 27 as to 64, it denotes what you call volume factor. It denotes what you call volume factor. So for you to find area factor, you need to raise what you call the scale factor by power 2. I hope you are following. Area factor, which is good as the ratio of curved surface areas, is found using scale factor raised by power 2. I hope you are following. Right. Then volume factor is found using scale factor raised by power 3. I hope you are following. So in simple terms, since the question has provided the volume factor, you need to find the scale factor first before you find the area factor. I hope you are following. So to find the scale factor, since the relationship between the volume factor and scale factor is VF is equals to SF to the power of 3, it means to find scale factor, you introduce a cube root. I hope you are following. So if I introduce a cube root both sides, cube root of 27, you get 3. Cube root of 64, it gives you 4. Remember, cube root, you'll be looking for a number which multiplies itself 3 times to give you the number inside the root sign. So 3 times 3 times 3 times 3, it gives you 27. Therefore, cube root of 27 is 3. Then as for 4, if 4 multiplies itself 3 times, 4 times 4 you get 16, 16 times 4 you get 64, therefore cube root of 64 is 4. So 3s to 4 is not your final answer, but 3s to 4 is representing what you call the scale factor. The required is the area factor, which is the ratio of their curved surface area. So for someone to find the area factor, you need to take the scale factor and raise it by power 2. It means I'm going to raise 3 by power 2 and I'm going to raise 4 by power 2. 3 squared you get 9, 4 squared you get 16. So 9s to 16 is the ratio of areas. I hope you are listening, class. Let us move on to question number 5. So question number 5 is in line with vectors. It reads, vector A is equals to column vector 3 minus 4. Find modulus of A. If you see these two lines, they denote modulus. So to find the modulus of A, we make use of the formula square root of x squared plus y squared, where x is representing the number above and y is representing the number below. So in this case, x is being denoted by 3 and y is being denoted by minus 4. We need to substitute 3 and minus 4 into our formula to calculate the modulus. So I'm going to substitute accordingly. You are going to say open bracket 3 squared plus open bracket minus 4 squared. So what is 3 squared? 3 squared, it gives you 9. Then you need to be very careful when it comes to minus 4 squared. If a negative number is raised by an even power, this negative sign, it disappears. So minus 4 to the power of 2, you get a positive 16 and not a negative 16. Because minus 4 squared simply means minus 4 is multiplying itself twice. Therefore, negative times negative, it produces this positive result. So you don't write minus 16, but you write plus 16. Be very careful when you raise a negative number by an even power. Right? 9 plus 16, you get 25. Then square root of 25 is 5. Remember, modulus, it contains positive values. It does not contain negative values. Since modulus, it means distance. So since distance cannot be negative, you don't write plus or minus 5, but you write positive 5. So your answer is 5 units. We normally express it in units. Then you are warm and dry. Let us move on to question number 6. Right, so question number 6 is in line with says it is requiring you to shed a complement intersection B union C. For you to shed a complement intersection B union C, you need to first of all represent those regions by numbers of your choice. You can say 1, 2, 3, 4, 5, 6, 7, 8. So we've got 8 regions, which are 1, 2, 3, 4, 5, 6, 7, 8. But you must not repeat the number twice. Like if you write 2 here, you don't have to repeat it 2 since you have written 2. Right, I want to find a complement first. The set of a complement. This a complement on my left side. What is the meaning of a complement? A complement is, we are looking for all numbers which are not in set A. I hope you are following. So in set A, we've got 1, 2, 4, and 5. So this set is going to be generated or created by numbers outside set A. We have 3, we have 6, 7, as well as 8. So this is your A complement. Then let me find B union C, which is the set on my right. I hope you are following. What is B union C? Union means join together. So joining together, I need all the terms in B and all the terms in C without repeating. So I'm going to generate my set using 2, 3, 5, 6, 4, and 7. 2, 3, then you write 4, 5, 6, and 7. So 2, 3, 4, 5, 6, and 7 are the numbers which are found in B and in C combined. I hope you are following, class. Right, so this sign in between A complement and B union C is intersection. Intersection means we need to identify common elements. By common elements, I refer to terms which are found in the A complement and at the same time appearing in B union C. So what are the numbers? What are the numbers? 3 is appearing in A complement and B union C, so 3 is a common element. 6 is also a common element, since 6 is appearing in A complement as well as B union C. 7 is also a common element as well, but 8 is not a common element, since 8 is being found in A complement alone, but it is not in B union C. So the numbers are 3, 6, and 7. So your final answer is going to be generated by shading the region which contain 3, 6, and 7. So I'm going to shade this part. I'm going to shade this part which contains 3, 6, and 7. So this is your final answer or your final result. So you can then rub these numbers, since they are not part of the question. You can then rub them, but your final answer is this one. I hope you are following. Let us move on to the next question. So we are now on question number 7. We are given a sequence which is 11, 13, 15, and 17. And they want you to find the 13th term, which occupies the 13th position. Right. So you need to start your pattern first. You can notice that between 11 and 13 there is a difference of 2. Between 13 and 15 there is a difference of 2. Between 15 and 17 there is a difference of 2. So to find the next term after 17, you are simply adding 2, 2, 2, and 2. I hope you are following. Right, so a sequence with a common difference, we refer to it as the arithmetic progression, or AP. For AP, we say the nth term is found using the formula A plus D, open bracket, n minus 1. A plus D, open bracket, n minus 1 is the formula used for a sequence with the common difference, which is known as the arithmetic progression. So what is A? A denotes what you call the first term. The first term. In this case, our first term is 11. So I'm going to put 11 on A. What is D? D stands for the common difference. The common difference is 2. So I'm going to put 2 on D. Then N means the nth term. The question is requiring you to find the 13th term. So our N is 13. You say 13 minus 1. So 11 plus 2, open bracket, 13 minus 1, you get what? 12. Right? So 2 times 12, it's now 11 plus 24. Your final answer is 35. So the 13th term is 35. So this formula, it helps you to find even the 200th term. You don't have to add 2 until you reach to number 200. You simply say U200 is equals to A is your first term, you put 11, plus D is your common difference, you put it 2. Then 200th term, it means N minus 1 is now 200 minus 1. I hope you are following. So you say 11 plus 2, 200 minus 1 is 199. Then you multiply 199 with 2. 2 times 9 is 18, carry 1. 2 times 9 is 18 plus 1, 19 carry 1. 2 times 1 is 2 plus 1, you get 3. So you now have 11 plus 3, 98. So if I add 11 on 398, you get 9. 9 plus 1 is 10, carry 1. 1 plus 3, you get 4. So your final answer is 409. So if you add 2, 2, 2, 2, and 2 to the 200th term, you get 409 as the 200th term. So this formula is simple to use. I hope you are following. Let us move on to part B. Now on number 7b, it reads, if the arithmetic mean of 5 and C is 11, what is C? So remember, mean is found by the formula summation of x over n, where x is representing the quantities. Like 5 and C, they are represented by x, right? Then this summation, it means you are going to add 5 and C. So on summation of x, I'm going to write 5 plus C, which is the sum of x quantities. Then you divide by n. N represents the number of quantities. So 5 and C are 2 quantities. So I'm going to divide by 2. So they are saying the mean is 11, right? So to find C, I'm going to cross multiply, treating 11 as 11 over 1. Then you cross multiply. 5 plus C times 1, you get 5 plus C. Then 2 times 11, it gives you 22. So to make C the subject, you are now moving 5 to the right. You get 22 minus 5. Therefore, C 17. 17 is your final answer. We are now on question number 9. It is in line with the topic of sets. It reads, given that this is the universal set, right? Given that universal set is equals to 1, 2, 3, 4, 5, 6, 7, up to 8. Sometimes they can give you is 1 less than or equal to x less than or equal to 8. Then you write 1, 2, 3, then up to 8. Right. So universal set is the supplier of other sets, right? So whatever you find in A, whatever you find in B, it must be part of the universal set. So there is no way you can have a number in A or a number in B which is not part of the universal set, since A and B, they all collect information from the main set, which is the universal. I hope you are following. So what I'm trying to say is, there's no way you can have a term like 10 in set A, yet 10 is not in the universal set. It does not exist. Each and every number that you see in A and B, it is found in the main source, which is the universal set. Right, here comes the first question. List A union B complement. So to find A union B complement, you first of all find A union B first. So what is A union B? Union means join together. So I need to join the terms in A and the terms in B without repeating. So in A, we have 1 and 8. Then in B, we have 2, 3, 4, 5, 6, and 7. So these are the terms in A and B combined. I hope you are following. Then this sign, A union B complement, this sign complement, it means we want the elements which are found in the universal set but which are not part of A union B. So now that we know A union B, we need to find the elements inside the universal set which are not part of this set. So what are those numbers? 1 is part, 2 is part, 3 is part, 4 is part of the set, 5 is part of the set, 6 is part of the set, 7 is also part of what? Of the set. So it means there is no number inside the universal set which is not part of A union B. So your answer is an empty set. You just open a bracket and you close a bracket and you don't write anything here to indicate that it is an empty set. Or you can write a 0, then you slash it. It means empty set. So this is how you write or you present your answer if you have an empty set. I hope you are following. Right, B it reads, solve the equation 25 to the power of x is equals to 5. So this is equation involving indices. 5 is treated as 5 to the power of 1. So you need to create same base both sides. So 25 can be written as 5 squared, right? Write 5 squared representing your 25, all raised to the power of x is equals to 5 to the power of 1. So you now have 5 to the power of 2x is equals to 5 to the power of 1. Now that you have same base both sides, you can now ignore the bases and concentrate on the powers. You get 2x is equals to 1. Then you divide both sides by 2. So your final answer is x is equals to half. This is how you solve. Let me give you another example so that you understand better. Right. 9 to the power of c minus 2 is equals to 27. They want you to solve this equation. So we need to create same base both sides. But there's no way you can create 27 using 9. So it means you are going to write 9 as 3 squared. Write 9 as 3 squared. Then you put open bracket c minus 2. 27 can be written as 3 to the power of 3. Now that you have same base both sides, you can now ignore the bases and concentrate on the powers. So you are saying 2 times c, you get 2c. 2 times minus 2, you get minus 4. Is equals to 3. Then move minus 4 to the right side, you get 3 plus 4, which gives you 2c is equals to 7. Divide both sides by 2. What do you get? C is equals to 7 over 2, which can be written as 3.5 or 3.5. I hope you are following. Let me find another example. 5 to the power of y divided by 25 to the power of y is equals to 125. And you are being instructed to find y. So what you need to do is, you can start by cross multiplication. First, you get 5 to the power of y is equals to 125 times the 25 to the power of y, something like this. So what I want you to notice is 125 and 25 can be expressed in the same base, which is 5. So on the left side, we are going to leave 5 to the power of y as it is, but 125 can be written as 5 to the power of 3. Then 25 can be written as 5 to the power of 2, but we have the power y, so 2 is going to multiply y to get 2y. So now you have 5 to the power of 3 times 5 to the power of 2y on the right side. So according to the laws of indices, if you multiply numbers with the same base, you add the powers. Meaning to say, 5 to the power of y is equals to 5 to the power of 3 plus 2y. Since I'm multiplying 5 and 5, numbers with same base, you add the powers. Now that you have same base both sides, you can cancel off the bases and concentrate on the powers. You'll be having y is equals to 3 plus 2y, something like this. So move 3 to the left, you get minus 3 is equals to 2y minus y, which gives you minus 3 is equals to y, and this is your final result. I hope you are following. You can also have a scenario whereby you have 7 to the power of 2x minus 1 is equals to 1, something like this, and they want you to solve for x. So remember, according to the laws of indices, any number raised to the power of 0 is equals to 1. So you can create same base both sides by writing 7 to the power of 0 on the right side. Now that you have a common base, which is 7, you now have 2x minus 1 is equals to 0, which is 2x is equals to 1. Divide both sides by 2. You get x is equals to 1 over 2. I hope you are following. Right? You can also have 0,2 to the power of 2m minus 3, right, is equals to 1 over 25. So what you need to do when attacking this question is, you first of all convert this decimal number as a fraction in its lowest terms. So 0,2 is good as 2 over 10, which is good as 1 over 5. So I'm going to write 1 over 5 on 0,2 to the power of 2m minus 3. Then 25 can be written as 5 squared. Then there is this law of indices which says that x to the power of minus a can be written as 1 over x to the power of a. In simple terms, I'm trying to say 1 over 5 can be written as 5 to the power of minus 1. So you are writing 5 to the power of minus 1 inside this bracket. Then you write 2m minus 3. On the right side, you write 5 to the power of minus 2. Applying this law of indices. So this negative 1 is going to multiply both 2m and minus 3. You'll be left with minus 2m, minus 1 times 2m, you get minus 2m, then minus 1 times minus 3, you get plus 3, is equals to 5 to the power of minus 2. Now that you have same base both sides, you cancel off the bases. So you now have minus 2m plus 3 is equals to minus 2, which gives you minus 2m is equals to minus 2. Then you move 3 to the right, you get minus 3. I hope you are following. So you now have minus 2m is equals to minus 2 minus 3. It gives you minus 5. Remember, when subtracting all negative numbers, you simply add, but the sign remains negative. So to make m the subject, you divide by minus 2. Minus 2 and minus 2, they cancel off each other. Negative sign and negative sign, they cancel off each other, leaving you with 5 over 2, which can be written as 2 and a half. So this is how you solve equations of this kind. You may also encounter this equation and you'll be required to find c. So what you need to do, you convert each and every number to same base. You can make use of base 2. So this is 2 to the power of c is going to remain the same since it is in base 2 already. Right, but 8 can be written as 2 to the power of 3. Open bracket, 2c minus 1, something like this. Then 32 is good as 2 to the power of 5. Then on the right, you have 2 to the power of 3c plus 1, something like this. So I want to cross multiply, treating this as 2 to the power of 3c plus 1 over 1, you cross multiply. So 1 is going to multiply 2 to the power of c times 2 to the power of 3, open bracket, 2c minus 1. You get 2 to the power of c times 2 to the power of, you can remove this bracket, 3 times 2c, you get 6c. 3 times minus 1, you get minus 3. So if you multiply, it is going to come as it is. Then on the right side, you are saying 2 to the power of 3c plus 1 is going to multiply 2 to the power of 5. So you are multiplying diagonal numbers. I hope you are following. So applying the law of indices, if you multiply numbers with the same base, you simply add the powers. So here I'm going to write it as 2 to the power of c plus 6c minus 3. So I'm multiplying numbers with the same base, so I'm going to add the powers. You get c plus 6c minus 3. Then on the right side, you get 3c plus 1 to be added with this power, which is 5. I hope you are following. So let me erase so that I have enough space. If you simplify c plus 6c, you get 7c minus 3. Then here you get 2 to the power of 3c plus 6. Then you cancel off the common base so that you concentrate on powers. You know, you have 7c minus 3 is equals to 3c plus 6. So move 3c to the left, you get 7c minus 3c is equals to 6 plus 3. It gives you 4c here is equals to 9. Then you divide both sides by 4. So what is 4 into 9? You get 2, remainder 1 over 4, and this is your final answer. Stay tuned as we move on to the next question. Question number 11, it reads, a die and a coin are rolled and tossed respectively. What is the probability of getting a 5 and a tail? So you can make use of outcome table. Remember, die, unbiased die number is numbered from 1 to 6. So you are going to write 1, 2, 3, 4, 5 up to 6. Then for coin, you have a head and a tail. So if the question reads 2 dice are thrown or 2 dice are tossed, you are going to number 1 to 6, then you number 1 to 6. If there are 2 coins tossed, the outcome table comes as HT and HT. Then for 2 dice, you have 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. But for a die and a coin, you have head and tail. Then you number 1 up to 6. So it depends with the situation. I hope you are following. So if you combine the left result and the upper part, you have 1H, and this is 1T. This is 2H. This is 2T. 3H, 3T. This is 4H, 4T. This is 5H, 5T. This is 6H, and 6T. So you'll be combining this result and this result. So how many outcomes do we have all in all? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We have 12 outcomes. And the question is requiring you to find the probability of getting a 5 and a tail. So a 5 and a tail is found at this position. We have 1 5 and a tail here. So your answer is 1 out of 12 outcomes. Then you are home and dry. So this is how you go about it. So what I'm trying to say is you may have a coin, right, which is being tossed twice. And the question may require you to find the probability of getting 2 heads. You write HT, then you write HT. So you combine H and H, you get HH. H and T, you get HT. T and H, you get TH. T and T, you get TT. So how many 2 heads do we have in the table? We have got 1 section with the 2 heads. So our required is 1 out of how many outcomes? 1, 2, 3, 4. So you get 1 over 4 as your answer. So this is the use of what you call outcome table. I hope you are following class. Right, let us move on to part B of the question.